In this video, our goal is to take the derivative of the function that you see right here. We're going to apply two different strategies to find this derivative. The main one I want to discuss is how would you go about using a product rule with a quotient rule for the derivative of a single function. So the product rule and the quotient rule are listed here. So you've likely used these if you're checking out this video. So if you're taking the derivative of a function of x times a function of x, you're going to take the derivative of the first piece times the original second piece plus the original first piece times the derivative of the second piece. Now this right here I always refer to as the skeleton for the product rule. The product rule is two things multiplied plus two other things multiplied. Similarly, we have the quotient rule listed down here, and the skeleton for the quotient rule would be two things multiplied minus two more things multiplied divided by something squared. I think using these as your structure to build within when you're taking derivatives is pretty helpful, especially if you're pretty early in your derivative career. So here is the function that we want the derivative of. This is a situation where we see a product and we also see a quotient. Now, there are times in calculus where you will have to nest one derivative rule within another. The important thing to do early within a derivative that you're going to be using that strategy for is identifying what the overall build for your particular function is. So is the overall build of this function right here a product, or is it a quotient? There's clearly a quotient right here, but I would argue that the quotient is the second part of the product. Right? This is the first part of the product. The quotient just happens to be the second part of the product. So what that kind of indicates to me is that I'm going to do my derivative within a product rule. And then as I use that product rule, what I'm going to have to do is the derivative of the first piece here, the original second piece copied here, the original first piece copied into this set of parentheses, and then in this final set of parentheses, when I do the derivative of the second piece here, what I'm going to have to do is I'm going to have to put a quotient rule in that position. So I'm going to be working within the structure of a product rule, and what happens is my quotient rule has to go into that last set of parentheses. So here is the derivative of this function. So the derivative of x squared minus 1 is 2x. I've got that in this first set of parentheses. In the second set of parentheses, I've copied the original second part of the product, so the original fraction that we saw. In this, after the addition, in this next set of parentheses, I've got the original first part of the function. And then in this last set of parentheses here, that concludes my product rule, what I actually have to do is I have to go through a quotient rule build. So I've got the derivative of the top part of this quotient times the original bottom part of the quotient minus the original top part of the quotient times the derivative of the bottom part of the quotient, and that's going to be all over the original denominator squared. Now this can definitely simplify. You'll have to pay attention to your professor, your teacher. Are they going to require for you to simplify your derivatives on tests, quizzes, homework, stuff like that? Main thing I wanted to discuss within this is how to successfully nest a quotient rule within a product rule. I feel using these skeletons and kind of mapping out a strategy before you just dive right into your derivative, especially early in your career of taking derivatives, is probably something that's pretty beneficial to do. Now, some of you might be thinking, well, why in the world did I do the derivative this way? I wanted to discuss this strategy, but I feel that what I've done on this screen is a far more efficient way to do the derivative of this function. If you can do algebra to avoid having to nest one rule inside of another rule, in this case, if I think of this first part of the product as a fraction, just put it over 1. If I just do top times top, bottom times bottom, when I do top times top, I am going to have to expand that. So it's a binomial times a binomial. So I've foiled that out. And then bottom times bottom is just going to be 1 distributed into x squared plus 2, which just keeps it as x squared plus 2. This now no longer requires a product rule. So you'll notice this isn't labeled as my derivative. This is a modified version of the function. To take the derivative of this, it would be a singular quotient rule. I'm not needing to nest one rule inside of another. So for this particular function, there are a couple different strategies you can use to find the derivative. Sometimes it's not really an option to do what we just clicked back from. Sometimes you're going to be forced to nest one rule inside of another.